Hi class, we're going to look at data that is bell-shaped, and in this case we're going to look at the spread of COVID. And what you actually see here is a normal distribution. So the following points are important. So this is point A, point B, and point C. So for a normal distribution, point A and C are important because of the following. So what you see here is your actual function is increasing, and beyond this point it's increasing faster. And if the data is bell-shaped, it's going to reach a maximum point here. Beyond this point, it keeps decreasing, and then it's going to reach this other point where it's actually no longer increasing, it's decreasing as time progresses towards infinity. So what I'm going to ask you to do is estimate these 2 points here based on the data set, and you can just give us a month. That's perfectly fine, because in this case it's actually needed. So let me show you. So this is actually, why don't we look at totals? Let me see if I refresh it. No, I'm actually on the map section, so I don't think it's actually going to give us the totals. I have to go back, not for the entire population. Yeah, no, I'm in another page. Okay, so let me wait for this to load. Okay, so this is what you're looking at. So the current mathematical model that we could use for basically predictions at the moment, it looks like a log. So let me show you what logs look like. So this is an actual log. And one of the problems with if the data happens to be logarithmic is that, well, if you see the spread as your y value, your actual spread is going to continue, and there's a problem, it continues forever. So definitely at the moment it seems to be logarithmic, but one main aspect that's going to occur is that we're going to get a vaccine. Assuming that everything works as expected, we're going to reach this point B. So probably that point B is going to be when we receive the vaccine, and then, well, not everybody in the world is going to have access to it. So you are going to see the cases decrease, and then at this point, it's when it should be safe for us to go back and everything going back to normal. As this increases, as time increases, the cases would actually disappear. So let me go back to the maps and the data. So if it's logarithmic, well, it's actually going to continue indefinitely, but something will happen at some point, which in this case, the vaccine, and then maybe make a bell shape. So you're looking at the following. Now, you're looking at, well, the actual confirmed values, and we were stopped and sent home around here. So around here is technically your point A. So that's when they sent us home. That point A was about March 15. I can't remember the actual date when the governor basically said everybody stay at home. Now, based on this data set, I want you to estimate basically what we have here. So that was your point A. I want you to estimate. Keep in mind that at the moment, we're in mid-June here. So what I want you to estimate is, when are we going to reach basically point B in terms of time frame? So time frame, we're talking about, well, basically that point B, this point B here. So all I want you to do is do an estimate. There's no right or wrong answer. Keep in mind that as of today, this is June. So I want you to estimate me, when are we going to reach this point B here, and when are we going to reach this point, technically C, month-wise. So all I need you to put in the discussion is, I estimate we're going to be in point B. This is assuming that it's bell-shaped, and then technically at some point we get the vaccine. And if it's just an estimate, if this were B, this is June, I just want you to come up with a month and a day. So at some point that's going to occur. This is honestly when the vaccine is available. This is when it's safe to go out. As you can see, It's not working as well it should, but I want you to just estimate when is point B and when is point C based on an actual date. So a month and a day will be fine. So keep in mind that as of today, this point here is June. So this is today. I don't know when you'll see that, probably today or tomorrow. So that's today. And I need you to estimate me technically those two coordinate points based on a date. You can just say on that one, July something, it's up to you. I don't see as we speak that this is turning around. So if you look at the data set in terms of the data that they're looking at, if I were to do a prediction, this is actually increasing. So the total numerical values for the world, it's not actually leveling out. Do you guys see what I mean? I don't see this happening here. I don't see this portion. I don't see this like stopping or reaching a maximum. And then what we would want to see is this portion basically going down. So all I want is an estimate. Tell me that point there, and then technically that point there, and then compare it with your actual classmates.